Alright, let's look at the homework 8.2, problem number 8. Alright, so we want to use Simpsons rule to approximate the area of a surface of revolution. Alright, so let's do that. Alright, first let's set up the integral. Alright, so surface S is going to be equal to, right, so we always have 2 pi in front, and then you have an integral. Looks like it's going to go from 0 to 5, right? Then radius is going to be just a function because this is a rotation about the x-axis. So function, so it's 1 over 5 x to the 5th power. Alright? Then width is going to be simply the arc length function. So it's a square root of, right, so 1 plus, right, we have to take the derivative. So find the derivative, dy over dx. It's going to be, so put 5, then the 1/5 and 5 cancel out. So it's actually just x to the 4th power, right? So square that, you have x to the 8th power, right? Then you have dx, right? Then what we want to do is we just need to evaluate, we want to approximate this integral value using Simpsons rule, right? So this is going to be approximated by Simpsons rule with n equals 10. Alright, so let's find the delta x. Alright, delta x is going to be, right, b is 5. 5 is right there. Alright, so it's going to be 5 minus a is 0. Alright, so we have a 0 over n. N is equal to 10. So you have a 10. So 5 over 10 is 1/2. Alright, so Simpsons rule, delta x came out to be just a 1/2 and divided by 3. That's part of the Simpsons rule. Right, then I'm going to call f of x, including 2 pi, and this integrand right here. Right, I'm going to call this guy, say, f of x. Then you just have to do Simpsons rule. So first number would be 0, so f of 0. Right, next one would be 4 times f of 0.5 because delta x is 1/2, and next one is 2 times f of 1, and so on. Right, and then second to last would be 4 times f of 4.5, and plus last one is f of 5. Right, let's compute this value. Right. So I'm going to bring out the Geogebra. Alright, so I'm going to define the function first. F of x is equal to, alright, so it's going to be x to the 5th over 5. So maybe I'll do that. Divided by 5. And square root times the square root of 1 plus x to the 8th power. Right, then I forgot to put the 2 pi, so I'm gonna put say 2 pi in front. Right, I think this would be fine. Right, hit enter. Then we should get a function there. Let's see. Oh, okay. Maybe I should put the multiplication sign here. Right, let's. All right. So we have. Actually, I didn't put the right thing. I need to put square root of 1 plus. Right, so hopefully this will do it. Right, so you have 2 pi x to the 5th over 5 square root of 1 plus x to the 8th. Right, so that's f of x. Right, so we have 1/2 over 3, so it's going to be 1 over 6, and multiply by f of 0. Plus 4 times f of 0.5 plus 2 times f of 1 plus 4 times f of 1.5 plus 2 times f of 2 plus 4 times f of 2.5 plus 2 times f of 3 plus 4 times f of 3.5 plus 2 times f of 4 plus 4 times f of 4.5. Actually, I put 4, and the last one is f of 5. Right? Hopefully this will be good. So click enter. Right? So we got this value. It's actually a really big number, and so then we have a nearest round to the nearest whole number. So it's going to be 1230507. Right? So let's type it in. Maybe I should write that down. All right, 123 and 0507. All right. 0507. All right, let's type it in. All right, let's see here. All right, we got the 1230507. All right, so let's submit for testing. All right, it came back and looks like we got the Simpsons rule correctly. All right. So we got that. Then we're going to use a calculator to evaluate the integral. Right? I'm going to actually use Geogebra to do that. So we want to integrate it. So we have integrate in, right? So integral, right? Function is f of x, right? Then starting value is 0 and ending value is 5, and then hit enter. Right? So we get 1227192. Alright, so 1227192. Alright, so let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.